homework 10, our video key. All right, number 1 has to deal with what we are learning on Tuesday. Which inequality is represented in the graph below? Well, first off, I want to take a look at, there's 2 different equations here of this line. All right, and I notice that in my graph here, we have a y-intercept of 4. All right, and automatically I should be able to pick out that 3 and 4 do not have a y-intercept of 4. All right, the next thing that I notice is that it's shaded above this line, and it's a solid line, okay, which tells me it's going to be greater than, and then the solid line tells me it's or equal to. So answer choice number 1 is correct, greater than or equal to. Number 2, most farm stand sold a total of 165 pounds of apples and peaches. We've actually done this problem in our notes before, but we're going to let A be the pounds of apples and P be the pounds of peaches. All right, and the total number of apples and peaches is 165. So that's where we get the A plus P equals 165. And $1.75 for each pound of apples plus $2.50 per pound of peaches is a total of $337.50. And we are looking not just for one, or not for both, but we're looking just for pounds of peaches. All right, so I'm going to be strategic about this, and let's eliminate the apples so that we don't have to do a bajillion steps here. All right, so if I want to eliminate the apples, remember that those are 1 and 1, I would have to multiply this equation by negative 1.75. So I would get negative 1.75a minus 1.75p equals negative 288.75. All right, and now I'm going to add down. The apples are going to eliminate. I'm going to get 0.75 pounds of peaches is equal to 48.75. And now to finally solve for the pounds of peaches, divide both sides by 0.75. And I get 65. So 65 pounds of peaches, which is answer choice number 3. Number 3, which equation or equations represent the graph below? All right, you got choice 1, 2, and 3. I put those all into my calculator, and I looked at the graphs, and we're just going to match which one it is, okay? Well, first off, we've got zeros at negative 2, 1, and 3. This one does not have zeros there, and this one also does not have zeros there. Negative 2, 1, and 3, that works, and it goes up to just about negative or positive 8 in the height. So answer choice, or equation number 2, is the only one that works. So answer choice number 2 is the only one that works. Number 4, a lab technician studied the population growth of a colony of bacteria. He recorded the number of bacteria every other day. Which function would accurately model the technician's data? Okay, well, always population of bacteria growth, that is exponential, but also between 0 and 4, it grew really, really fast from 25 to over 9 million. So I'm going to go ahead and say this is not linear. So I'm going to cancel out 3 and 4 as answer choices. So then I'm going to go into my calculator. All right, and I'm going to look at the tables of answer choice 1 and answer choice 2. And I'm going to find which one matches. So at 0, I should have 25. 0 and 25. Y2 is looking like the right one. 2 and 15,000. 2 and 15,000. Yep, answer choice number 2, or Y2, which was 25 to the x plus 1. So answer choice number 2 is the correct one. Number 5, what are the zeros of the function x squared minus 13x minus 30? Well, that's, remember, when y equals 0. Zeros. Okay, that's when it crosses the x-axis. All right, and I'm going to take a look at this table. I already have these all typed in. So I'm just going to turn on Y4. And I'm going to look at the table, and I'm going to find where my zeros are. All right, I see a 0 at -2, 0. So it looks like answer choice 4 is the only one that's got -2 is one of the zeros. Okay. Number 6, another system of equations. Albert says that the two systems shown below have the same solution. Okay, well, in gray, you can pause it, but I already solved for x and y here. And I find that the solution for that one is -3/4 for x and 6 for y. Okay, solving for y was really pretty quick in the second system because the second equation only has y's. All right, now if we take a look at the first system, 8 and 12 don't really go together, and 9 and 5 don't go together. But if you remember, we can multiply by some other number. They share a multiple of the number 24. Okay, so if I multiply 8 by -3, I'll get -24. And if I multiply 12 by 2, I'd get a +24. So I went ahead and did that. All right, and now we are going to solve like we've been doing in class recently. So I'm going to add down, and I get -7y is equal to -102. Divide both sides by -7. Wait, that doesn't seem right. Oh, sorry, -17. And I get y is equal to 6. All right, so far so good. They both have y equals 6. Now remember how we find our second value. All right, we're going to take it and we're going to substitute it in for x. Or I mean for y in this case. So 8x plus 9 times 6 equals 48. Or 8x plus 54 equals 48. Subtract 54 on both sides. And I get 8x is equal to -6. Divide both sides by 8. And I get that x is -3/4. So we got the same solutions. So we agree Albert is correct. And justify your answer means show all of your work, which we just did. Number 7, John and Sarah saving money for a car. John's got f of x as his function, and Sarah has g of x as her function. The question is, after how many weeks x will they have the same amount of money saved? Explain how you arrived at your answer. All right. Well, I typed into 2 different y values, or two different y equals, so I could look and see when are they equal. All right, meaning when do they have the same y value? And I find it happens right here. All right, when x is 7. All right, so we're going to go ahead and say that after 7 weeks, they will have the same amount of money. And it says, explain how you arrived at your answer. I typed both into y equals and found in the table where they have the same amount of money in the y's. Okay. Number 8, the residual plots from 2 different sets of bivariate data are graphed below. Okay, residual plots have to do with the scale of the stuff. I mean the scatterness of it, okay? Which indicates the model is a good fit. Graph A because it's scattered. I am running out of time. Okay. For number 9, you have to run an exponential regression. So you would get y is equal to 80 times 1.5 to the x